In this video, we will do a step-by-step guide on fine-tuning the Z-Image LoRA using the software called AI-Toolkit. So this works on a 12 GB of VRAM Nvidia GPU. Here are the minimum requirements that are needed. For the hardware, you will need an Nvidia GPU, at least 12 GB of VRAM. For system RAM, recommend 32 GB. And because of the fine-tuning, also recommend 100 GB of disk space to save all those model files. For the software side, I'm using the Linux. You can also use Windows with WSL. For the Python, you will need a virtual environment, either with the VENV or with Anaconda or Miniconda. So here, let's do a step-by-step on how to install and run it. So make sure that you meet the minimum requirements. So for example, this is my server that I logged in. As you can see, it has a Ubuntu 24.04. What we want to do is to basically to first git clone the repository. So this is the AI-Toolkit GitHub repo. So you would need to copy that to your server. All right, and then change your directory to that. Once you change your directory to the AI-Toolkit location, the next thing to do is you will need your Python virtual environment ready. Either you can use the Python's VENV or you can use Conda, like Miniconda. So I will use the VENV. So let's try the VENV. Okay. And then you will need to activate it. So it will be source VENV bin activate. As you can see, after you run this command, you will see that there is a prefix. So VENV, which means that you have the Python virtual environment activated. So which Python? As you can see, right, you double check it. So make sure that you can see that it's VENV. So basically it created a separate folder for the virtual environment. That's what you really need. Okay. And so I think then the next you will need to, so basically you can see like what package already installed. So you can see it's here only have like a PIP here. Okay, so next we'll need to install the torch. So one trick I think you may try is to make it faster. You can use the package manager called UV. So pip install UV. Already, and then after you install the UV, you can see that you can just use the UV pip install. You can add the UV to here. Yeah, and the rest are the same. Press enter. So this command, because it's installed a torch, which is a big package, it's also installed some of the CUDA from Nvidia packages. So it can take some time, depends on your network speed. I think the UV is really like a speed up compared to the regular pip. So I really highly recommend you to try it. Similarly, you can basically add the UV to the other command too. Already, we see that to install everything, and we can do a quick check. Yes, it installed the torch 2.7 with the CUDA 12.6 and the torch audio, torch vision. Looks great. And the next we will need to install is the requirements.txt from the repository, from the AI-Toolkit repository. So just copy and run it. Okay, we can remove the 3. Yeah, it doesn't recognize the 3, I think. Wow, that's really fast. Great job. I think we installed everything. So now the next part to install is there is a user interface, so which make it really easy. Otherwise, you need to do the fine tuning to the setup on the command line. With that user interface, the UI, you can just go to the web browser and you can operate everything there. So I think that's really, really convenient. I really highly recommend that. So the installation is also pretty easy. One dependency is that because it uses the React with Next.js, so you will need a node, this JavaScript to do that. If you don't have the node, so you can quickly double check the node version. As you can see, I have it here. If you don't have it, you can do an installation on that. So this one is all you need, just to make sure you run it. And then after you have that, you can just change the directory to the UI, and you can like run the build and restart command is here. Press enter, so it will start the building, and then it will start the user interface. It will give you a URL address you can log in. We see that it shows us it has been successfully started and it's ready. And the network, if you want to how to open it, if you are on the same PC, you can use this local host. If you are on the network, you can just use this one. So I will copy this one. So I will copy this address to my web browser and press enter. Wow, congratulations. I think then you can see that the user interface is right here. Great job. And I think it will list the GPU in your server. So for example, in here, I have 3 there installed, 3060, 3080 Ti, 3060. All of them have 12 gigabytes of VRAM. I'm not sure if it supports like a multi-GPU. However, for the single GPU, it works great. So we will be focusing on the 3060. And the thing is, it's great is that it lists everything you need. So for example, you need your training data, right? The data set is here. And then once you have your data set, you can create a job and then it enters the training queue. That's where you start the training. So I think that works conveniently. I will show you how to create a data set. So first, you click the data sets the button on the left panel. You see that it opens the data sets interface. I already created 2. However, if you want to create a new one from scratch, so just press the new data set. You give it a name, new train 1, and press create, and then you can drop your image there. Yeah, so for example, I want to train the Ghibli style. So this is from the ChatGPT output. So I want to like train them. So I like select those and drag and drop them here and release. You can drag more to it. Yeah, and I think that's it. And also a good thing about it is that you may not need to provide the caption. However, if you want to like better control it, you can provide a caption to it, but that's not required. So you can perfectly fine, you just provide your image to that. And even the dimension doesn't matter too much, because usually it's just not too small or too big. It just shouldn't be a problem. And I think that's it. You can see that. You can see that my newly created data set is here called new train 1. And in terms of the create new job is here. So in here, there is some lots of default settings. You can leave them as is. First, you can give it a training name. My first Z-Image Fine-Tune. And you can select your GPU. If you have multiple one, you can select 0, 1, or 2, and you give it a trigger word, something like not recognizable. You can just call it a name like ty. Yeah, so basically it can be like a unique identifier for the fine-tuned LoRa. So that's it. And then you choose your model. We want to choose the Z-Image with training adapter is here. So it will show you the name or path, and this one are default. You don't need to change them. The first run, it will download it from the Hugging Face, so it will take a little bit some time in the first run. So you will see that you have a low RAM, VRAM enabled, and I think this one is important, especially for 12 gigabytes of VRAM. You will need to want to offload the text encoder because this is not important. The only important one is the transformer. So for the transformer, you also want to offload some. And 80. And here is it defines like how much steps it can save. So every 250 steps, it will save it to a checkpoint, which you can use. So if you want to either decrease it or increase it, so these are both fine. And on here, so this is the training default. You can leave them as is. And for the data set, so you make sure that you select the one you want, right? Okay, and then I think the rest is you keep them as is. So for here is also as is. And the last thing is there is some sample prompts. So this one we'll use to do a validation of the fine-tuned LoRa. So for every 250 steps, it will start running the generated LoRa and to see how those looks. So you can see those in like real time. So I think that's also a great feature. All right, so make sure that you can just change and modify those based on your data set. For here, I will just remove some of them, and then you can add them too. Yeah, so those not be a problem. And after everything here, we can also want to give it a good name, and then we can create a job. Yeah, once it's created, it directly shows you the training interface. So at this stage, the only thing you will need to do is to click the Run button. It's on the right side corner is here. So as you can see, it shows you the information of your system. There is CPU, there is GPU. It also shows you the progress. So in the samples, it will show you all the images generated. And this is the configure file here. Yeah, the configure file is useful if you want to use them like on just a command line. So you can use this one very conveniently. But this is the user interface, so you can see it like visually, like how everything goes on. So let's press terminal window is here, and on the right side you can see like what's going on with the GPU, with the GPU load, with the GPU memory, and also with what's going on with the system memories here. Run to get it started. It just shows the progress on the. Yeah, so now I think it uses our sample prompts to start generating the baseline like images. So here you can see that it's right here, and we can see the GPU load 100%, the memory at 75.1% usage, like which equals to 9 gigabytes out of the 12 gigabytes. And we can also see everything like temperature, the power draw is here. Also, we notice that the system RAM is used at 19 gigabytes, so make sure that you have enough system RAM for it. Yeah, so I think once the image is generated, you can click the samples tab here, so it will show you what's it look like. So we see that it just started the training process. So as we set up is 3,000 steps. It will start from the 1 to 3,000. And on the right side, it shows you the progress bars here. So because the 3060 is not really fast, so it takes a very long time. However, I think 5 to 6 hours is still acceptable. And on the right side, you can see all those informations here. So 100% GPU load, and the memory used around 11.2 gigabytes. So if you click the samples, just shows you a baseline image. We can then compare it once we have some trained LoRa images here. After 6 hours and 56 seconds, the training on the 3060 has been completed. Wow, that's really awesome. So from the initially beginning to the end, I think it shows you all the logins. You can examine them carefully. And on the right side, as I showed earlier, it save all the checkpoints for every 250 steps. So you can download them and test them. And also along the training, you can see that there is some validation images has been generated. So you can take a look at those. Simply click the samples tab. Yeah, so I think from beginning to the end, it will show you the progress. So this is at the beginning of the training. So everything is from the Z-Image, the base model. And then along the way, you can see how to change. Some of the color tones has been gradually changed, right? And especially around this side. So here, we can see that it's very much similar to what the import images style look like a Ghibli Studio style. So here, and especially it's here, from here ongoing, it's about 2,750 steps. So this is the last one is 3,000 steps. So I think if you want to continue, you can continue from the 3,000 steps. So it can give you like a better replication of the original import training images style. So I think I will leave it to you to experiment with that. But I think as you can see here, I think it looks very, very different from the baseline model generated images. So I think that shows that the LoRa has been working, right? So that's great news. And then if you want to just generate more, you can try different checkpoints that has been saved to the server. You just download them and load them into the comfyui workflow and to test them. Once you save the LoRa model into your comfyui location, and then you can load it. So here I'm showing you a GGUF workflow hookup with the LoRa loader. So we created it right here, and then we can enter our prompt. So automatically the LoRa will be applied, and then so for example, this is the generated image, right? So that's very similar to what our input image look like. Yeah, it shows that the LoRa has been really working great. So overall, I think this is a very smooth experience to train the Z-Image LoRa. So I hope you find it useful, and please share in the comment if there are some LoRa you want to share. Feel free to post them as well. Thank you for watching. Please give it a thumb up and share it. Please subscribe to the channel for future content. Thank you for your support. Goodbye.